Next, we will cover the business use case, discussing target customers and use cases. The four use cases we'll cover are unified networking with DC expansion consolidation, layer 2 mobility and disaster recovery, automation, and scaling the infrastructure. The first use case is unified networking, enabling easy DC expansion and consolidation by providing connectivity for all the virtual workloads, VMs, and containers. Here we see that without NSX, VM mobility is limited by the span of the VLAN and virtual machines are tied to the physical network. If you look at the diagram on the left, you have subnet A and you've got some workloads that are sitting in subnet A. You have some open capacity in subnet B and you'd like to move those workloads into subnet B, but you're not able to without changing the IP address. Oftentimes the IP addresses are hard-coded, which means you have to refactor the application, making it more difficult. It's not generally practical to do it all over again when you want to move that workload into subnet B. When a VM needs to be moved from, say, one rack to the other, often they cannot be moved easily because the source and destination subnets are different. So what an NSX does is create layer 2 tunnels. The layer 2 tunnel will connect this VM back to the original subnet. You can see we have VM2 sitting in subnet B. It thinks it is in subnet A, and this is the way that you provide mobility to move workloads from subnet to subnet without changing the IP address. This also provides the ability to deploy services in a very similar way. In this way, we virtualize the entire networking stack. With NSX Overlay Network, you can extend a network over an existing physical network, decoupling the VMs from the physical networks. The overlay tunneling protocol used is Genevieve. Logically, VM1 and VM2 are on the same subnet, which has been stretched across racks. There is no hardware dependency, and there are configuration changes required to the physical infrastructure. Virtual networks can be instantiated very quickly with a single API call or with a few clicks in the UI. And the VM IP addresses are independent of the physical network and can be moved easily. NSX also provides a converged solution for VMs, containers, and bare metal networks. This approach is to use complete layer 2 to layer 7 network services for VMs, containers, and bare metal. It provides support across Tanzu Kubernetes Grid, vSphere with Tanzu, and upstream Kubernetes. The benefit is it provides consistent policy for developers using Kubernetes and operations managing the infrastructure. It also provides converged network and security operations for VMs, containers, and bare metal. Next, we'll look at use case 2, which is the use case for mobility and disaster recovery within multiple data centers and sites. Overlay networking is a powerful capability that enables use cases such as VM mobility, layer 2 data center extension, multi-site networking, and disaster recovery. Some of the business needs for workload mobility are dynamic placement of workloads anywhere in a data center or across sites, onboarding new applications quickly without network constraints while preserving security, and data center consolidation and refresh, migration, merger and acquisition. The solution to this is NSX, which enables software-defined networks to stretch across racks and data center boundaries, provides onboarding of new applications while preserving IP addressing, allows you to move security and services along with the workload, and provides path optimizations and local egress capabilities. In the top left, we see VM mobility that allows you to move a workload between racks on the same subnet. The same concept applies for layer 2 DC extensions where you can move workloads between data centers on the same logical network. You can deploy applications across multiple sites in an active-active configuration, providing high availability for your applications. And it also provides disaster recovery capabilities to move workloads across physical sites in case the production site experiences an outage. Next, you look at use case 3, which is the use case for simplifying and automation of day 1 and day 2 operations. To understand the benefits of NSX automation capabilities, let's look at how applications are deployed without NSX. We start with an admin deploying some VMs. The admin needs to configure VLANs in the host. Next, a networking admin needs to be engaged for VLAN configuration on switches and routers and router configuration. The network security team may need to be engaged to configure firewall policies, and a load balancer admin may need to get involved for any load balancer configuration that is required. And finally, an admin will need to ensure all the routing is in place for traffic flow. As these processes are usually ticket-driven, it can take days or even weeks to get the configuration completed, and it also involves the element of human error. Now let's look at the same scenario with NSX in place. Here we have 2 subnets, and again we start with an admin deploying VMs. With a single API call, the networking infrastructure that's required for that application is deployed. There are no handoffs, no dependencies on physical infrastructure, and all of this is deployed in minutes. And this is the power of network virtualization. This does require you to create the automation to accomplish this task, but the payoff greatly outweighs the cost of development, especially when this a repeatable process. Next, we look at private cloud automation with VMware Cloud Foundation, allowing you to build your private cloud with VCF and NSX. The business needs are to build a public cloud experience on-prem, provide agility and scaling on demand, secure applications and infrastructure, and reduce time to market, CapEx and OpEx. And the solution is VMware Cloud Foundation, which provides a consistent, standardized, automated stack to build a modern private cloud. And NSX is pre-configured in the VF stack and provides the foundational layer for building the private cloud stack. Next, we'll look at the last use case 4, which will cover scaling your infrastructure, allowing you to optimize server utilization and deploy anywhere at any time. NSX allows infrastructure optimization for scale out and refresh. Enterprises use NSX to connect, simplify, and optimize data centers without causing disruptions. NSX works with traditional multi-tier, 3-tier type architectures and flatter next-gen fabric architectures. The result is a common platform with the same logical networking, security, and management model. We will look at an example optimization and consolidation scenario with CapEx savings for compute infrastructure and integrating information systems following mergers and acquisitions, maximizing hardware sharing across tenants and multi-tenant clouds, and accessing islands of unused capacity. Here's an example of how NSX enables CapEx savings, showing data center defragmentation. NSX accomplishes this by allowing server workload optimization. NSX assures optimal use of data center compute by removing islands of unused compute capacity, removes the necessity to over-provision compute resources, no need to reconfigure the physical network to leverage total compute capacity, and reduces errors in configuring the network for TTM for new applications and scaling current application needs. On the left, you see an example of how NSX can lead to CapEx savings, showing the difference between the 5-year cost without NSX versus with NSX, and in this example, leading to an 88% reduction in CapEx.